Can scientists hack memory? Modern science brings us endless possibilities to help our bodies and our minds stay healthy, but some recent scientific pursuits have also been the center of controversy. One of these is researchers' interest in manipulating memories. Is this feat possible, and if so, why would we want to achieve it? Our memories make up so much of who we are, and the things we remember can often define our experience of the world. And while positive memories can help us grow and thrive, negative memories do not always have such welcome effects. Sometimes, unpleasant memories can be part of a learning curve. Getting scalded with boiling water means that next time we will be more careful when handling the kettle. The study of memory formation, recall, and forgetting attracts a lot of attention and curiosity among neuroscientists, psychologists, and even researchers from the humanities, as there is still so much we do not fully understand about the processes surrounding memory. And, while we still need to find out more about how memories form in the brain, researchers in recent years have started investigating the possibility of manipulating memories, particularly negative ones, to see if they can weaken or remove them altogether. Memory recall and forgetting. When the brain encodes information, those data become stored in groups of neurons, that synapses or links that allow brain cells to connect together. Scientists typically associate stronger synapses with a better memory, and the brain constantly updates synaptic connections, forming new ones or strengthening old ones, as new memories build or we update older ones. However, synapses can also become weaker if they are not activated often enough, and the brain often loses some of these connections altogether. Thus, forgetting can occur naturally and, indeed, researchers argue that forgetting is a crucial part of learning and creating new memories. Memory conformity and distortion. Past research has shown that social interactions can influence a person's memory of an event, as can what other people remember or claim to remember about the same event. According to a report in the journal Science, conformity may present in two forms, which initially convey similar, explicit behavior but are fundamentally different. These are private conformity, in which an individual's recollection may genuinely be altered by social influence, resulting in long-lasting, persistent memory errors. Public conformity, in which individuals may choose to outwardly comply, providing an account that fits that of others, but inwardly maintain certitude in their own original memory. Forgetting as an adaptive mechanism. On top of the issues surrounding how we remember the things that we remember, there is also the problem of why we forget, and some researchers note that forgetting sometimes occurs as an adaptive mechanism. Disrupting intrusive memories. But what happens when traumatic memories persist and resurface unbidden? Experts call this the intrusive re-experiencing of trauma, and it is a core feature of PTSD. Individuals who experience PTSD may spontaneously recall a traumatic memory, or feel as if they are going back into the context that produced the trauma. This effect can cause the person severe distress and lead to erratic behaviors as a coping strategy. For this reason, some scientists have wondered what approach they could take to weaken or manipulate negative memories and lessen their effect. And, we already know that it is possible to interfere with a memory and stop it from solidifying. Studying memory manipulation. To try and understand whether or not we can artificially manipulate memories, a team of researchers from the Massachusetts Institute of Technology in Cambridge first tried to instill false memories in mice. This initial study, which appeared in Science in 2013, used an optogenetic technique to manipulate the formation of a hybrid memory in the mice's brain. This method requires the use of light beams to activate neurons that researchers have engineered to respond to this stimulus. Human versus animal brains. But are such studies in animals truly indicative of what would happen in the human brain under similar circumstances? Behrens told us that, while there are indeed some discrepancies between human brains and the brains of non-human mammals that researchers usually work with, the similarities are strong enough to give us a good idea of how human brains would work in the same context.